Today we are going to be doing a insulation energy transfer experiment. We are going to be doing this by putting the same temperature of water into 4 different types of cups. Each cup has a different material, so we will be working with glass, ceramic, plastic, and metal. We will be testing how each cup prevents the transfer of energy, so how it insulates the liquid inside, and which cups let out the most energy, so the most energy transfer is happening. So to start, can any of you answer what insulation is? And then the students might say, insulation is the materials that resist the transfer of energy. And then after this, I would say, well, what is the transfer, or what is energy transfer? And then they might say the movement of energy from one place, thing, or system to another. I will be giving each of you a sheet of paper that has a table on it, as well as some different outlined questions regarding the scientific method. So in our table, we will have columns that have in each row glass, ceramic, plastic, and metal for each 4 of our cup materials. And in each column, we will have our starting temp, so we will write that down, as well as our temp at 5 minutes, 10 minutes, 15 minutes, and 20 minutes. Through this, we'll be able to see which cup maintained the temperature the best, which one did not transfer the most energy out, and which one dropped the most in temperature, which one transferred the most energy out of it. Before we start, I would like each of you to write down your prediction for which cup will lose the most energy and drop the most in temperature, and which one will have the highest temperature at the end, meaning which one transferred the least amount of energy. And then after that, I would like you guys to put this in a form of a hypothesis. Okay, so now that you guys are done with that, while you've been doing that, I have put water into each of our cups. So now you can see there's some water in them. The main jug that I poured into it was at a 120.2 degrees. So each one has exactly 1 cup measured out of 120.2 degree water. So I'd like each of you to put in your first column under starting temp 120.2. Now for the next 5 minutes, I would like you guys to discuss with your partners what you guys predicted and I hypothesized for what's going to happen to each of the water temperatures in each cup. All right, so our 5 minutes is up, so we will be taking the temperature of each glass. It takes a little bit to get to a stable temperature. All right, so for glass, it will be 102.9 degrees. So under glass, everybody in the class write 102.9 degrees. Now we will be doing ceramic. For ceramic, we were at, oops, moving a little bit, 104.7. So under ceramic, write down 104.7 degrees. For our plastic cup, we have 111.4 degrees. So that's for plastic after 5 minutes. And now for metal, we have, gotta give it a second, 114.6. All right, so for metal, under your 5 minute column, write down 114.6 degrees. So from that, we can see that glass dropped down to from 120 degrees to 102. So it dropped very quickly. And under ceramic, it dropped pretty quickly, not as much. Plastic, it dropped down to 111.4 degrees. And metal, it dropped down to 114.6 degrees. Professor Fetty, just as a disclaimer, for the last video, the first time I did it, I messed up my speech, so I had to do it again. That's why I wasn't writing down, but this time I will be writing down, so insane. All right, so after 10 minutes, we will be taking our temperatures again. So for our glass cup, this will be under our 10-minute temperature column. we have 97.8 degrees. So we can see that it dropped about 5 degrees that last time. For ceramic, our temperature is still rising. 100.4 degrees. So under ceramic, write down 100.4 degrees. For plastic, we have wow, 102.7 degrees. So as you can see, after the first time, it was the second highest temperature, and now it has dropped significantly down to 102.7 degrees. Now we will be testing our metal cup, and the water in our metal cup is at 109.9 degrees. All right, in another 5 minutes, we will be checking the temperatures again, and that will be our 15-minute mark. All right, class, so now we are at our 15-minute mark, so we will be taking the temperatures of each one of our cups again. Just like the first 3 times, we will be taking it out of our our glass cup first. So our glass cup is at 96.3 degrees Fahrenheit. So we will write 96.3 under glass for a 15-minute column. Now we will be doing out of our ceramic cup. It shows 97.9 degrees Fahrenheit. Now we will be doing our plastic cup. We're at 100.8 degrees Fahrenheit for plastic cup under 15-minute mark. Now we have our metal cup. Wow. It's moving. We have 107.1 degrees Fahrenheit for our metal cup under a 15-minute column. Now we will be doing another 5 minutes, and then we'll be able to look at our data and see which one lost the most amount of energy and which one resisted the transfer of energy the most. All right, class, we are now at our 20-minute increment of our experiment, so we will be taking our final temperatures. We're going to start once again with glass. I have to give it a second. For glass, we're at 91.2 degrees Fahrenheit. Now we are going to be doing ceramic. And again, this will be under the 20-minute column. We're at 93.4 degrees Fahrenheit. And now for plastic. Ooh. It's going up on me. Give me a second. It is at 95.2 degrees Fahrenheit. And now for our last one, metal. Remember last time, metal had the highest temperature through our last 2 5-minute increments. Actually, all three. I am corrected. It has had the highest temperature so far. It is already up to 100 and still going. It is settling at 102.9 degrees Fahrenheit. I'll give you guys a second to write that down. Okay, now that you guys have finished that, so from our experiment, we can see that each water temperature in each cup started at 120.2 degrees Fahrenheit. Now our glass cup ended off at 91.2 degrees Fahrenheit. So it dropped about 19 there. Now our ceramic cup dropped from 120.2 degrees Fahrenheit to 93.4 degrees Fahrenheit. So it dropped about a little under 17. Now our plastic cup, the water in our plastic cup also started at 120.2 degrees Fahrenheit and dropped all the way down to 95.2. So it dropped a little under 15 there. Oh, I'm sorry, 25. Yeah, excuse me, it's dropped about 25 degrees, and our ceramic cup dropped about 27 degrees, and our glass cup dropped about 29 degrees. Now our metal cup started off at 120.2 degrees, and it dropped down to 102.9 degrees. So that one dropped about 17 degrees, about one-tenth over 17 degrees. Now I want you guys to look at your predictions and your hypothesis, and I want you guys to write down the results of each cup, how much it dropped, and what the starting temperature of each temperature of water in the cup was, and what the ending temperature of each cup of water was. Now that you've done that, I want you to look at your predictions and your hypothesis and look at the fourth question that we have. And it is, how did your predictions compare to the result of the experiment? Now I want you guys to think about that and write it down. And afterwards, I would like you guys to talk to your table partners and discuss how your predictions compared to the results. After you've done that, I want you guys to write down, what did you learn about energy transfer? That will be number 5 on our scientific method questions. So this will be comparing results, and then now, what did you learn? After you're done with that, I will discuss one more thing with you guys. I'll give you some time. All right, so I will have a couple of you guys share. So raise your hand with what you learned about energy transfer and if your predictions and your hypothesis ended up being right. Okay, thanks for sharing. So as you can see, our metal cup had the least amount of energy transfer out of the cup. So it insulated the liquid inside it the best. And our plastic cup was next, and it at 95 degrees. So not as good, it didn't insulate as much as our metal cup. A little more energy was transferred out of the cup. And then next is our ceramic cup. So even more energy transferred out, and it at 93.4 degrees. And then our glass cup, it insulated the liquid inside the least. So the most energy was transferred out of this cup, and the most energy was kept resisted from transferring out of the cup in our metal cup. Hopefully you learned something about energy transfer and what materials prevent transferring of energy and which ones energy transfers out of the most. Thank you guys for paying attention.